Dear students, very good afternoon. Today we are going to discuss about network diagram representation. So what is a network? Network, we are having two events that are connected by an activity. Okay. So this is one and this is two, means here we will have an activity A. So here A represents an activity and 1 and 2 represents events. So events are called nodes. Events are called as nodes. NODS. Events are called as nodes and they are represented by a circle. Okay. Within circle you will have an alphabet or any constants. Okay. And activity is represented by activity. Activity is represented by arrow diagrams. Okay, by arrows. Okay, so over the arrow you will have an variable. Okay, on many occasions it will be variable. Okay, so there are some rules to make this network. The first rule is there should be no loop. There should be no loop. Second rule is we have to add dummy activity. Okay, dummy activity when there is a situation of making two different activities with the same name. So on such a case we have to add dummy activity, and I shall explain that with an example. The third situation is there should not be an intersection of any activities. Okay, no activity should be intersected. And the fourth condition, so actually there are only three conditions, but this is the fourth condition that is hidden in your network diagram representation. So there should be only one activity. between two nodes. There should be only one activity between two nodes. So there should not be another activity between the same two nodes. Okay, between the same two nodes. If it is so, it is wrong. Okay, so these are the four rules. Now for our problem, P, Q, R and S, T are given as the 5 different activities. P, Q, R have no immediate predecessors, but S and T have P, Q as predecessors and Q, R as predecessors. So okay, now we shall represent this as the network diagram representation. So first let me draw the. Okay, so this is our first event. Okay, from which I have to start three different activities. So what do these three different activities represents? So whenever we draw the activities, we have to draw the arrows. So first arrow represents P, the second arrow represents Q, and third arrow represents R. Why we have drawn like this? Because P, Q and R are the three different activities that is having no predecessors. Okay, that is having no predecessors. So we have to begin that. So after that I have to write uh, 3. I have to write another variables within the within another constants within the next circles. So if I take this as 2 and this as 3 and this as 4 means then I have to represent next activities. Okay, so the condition given here is okay, S and T have union predecessors P and Q. Both K is having predecessor, that is P and Q, and T is having predecessor Q and R. Okay, so S is having P and Q and T is having Q and R. So in order to represent both these, we have to make only one event or node. Okay, only one event or node. Okay, so what does it will be? It may be yes. So now P is the predecessor of S. Also Q is also predecessor of S. Q is also the predecessor of S. So we happen to draw like this. If I draw like this, then it will be wrong, because here again I have to draw S. Okay, so yes, P is the predecessor of S, Q is the predecessor of S. So definitely it will be wrong. So that is why we have to use dummy activity here. Okay, so dummy activities are always represented by dotted lines. Okay, so the numbers should be arranged in ascending order. The arrows should be pointed towards ascending order of numbers. Okay, so 1 2 3 1 2 2 2 3 3, like in this manner only we have to arrange the numbers. So this activity is called dummy activity 1, first dummy activity. Okay, now we can see P is the predecessor of S, also Q is also predecessor of S. See here how Q is also the predecessor of S. So through this dummy activity, Q is also the predecessor of S. Okay, then again now let us draw T. So R is the predecessor of T. Whereas we are having one more activity. That is Q. See, T is having my predecessor R and T is having predecessor Q. So for that, if I write here T, then we can see T is having the predecessor R, and I want to have another predecessor Q for the same T. So I am not supposed to join here the same T. Okay, then T can have Q, T can have R, but if I do like that, it is wrong. So that is why I have introduced this dummy activity. So through this dummy activity, R is the predecessor of T and Q is the predecessor of T. through dummy activity. So this new dummy activity is called D2. This new dummy activity is called D2. Okay, this two dummy activity is called D2. Okay, I hope everyone understand this. So now let us move on to the second problem. Okay, so draw a network for a project whose activities with the predecessors relationships are given below. So P, Q and R are having no predecessors, so these are the starting activities, whereas S is having two different predecessors, T is having two different predecessors, and U is also having two different predecessors. So P is having common here, P is common here, so we have to make P in between. Okay, and 2 should be there. Okay, and let me explain how to do that. Okay, so first we shall draw PQR. Again it starts with 1, and I have to draw 3 different activities. Okay, 3 different activities. So here I am writing another circle. Okay, I am drawing another circle. Okay, so now I am writing 2 here, and then 3 here, and then 4 here, and then 4 here. Now if I mention this as P and this as Q, and now this as R. Okay, the 3 starting activities, that is the activities those predecessors are over. Now I have to draw STU such that S is having P, Q as predecessor, T is having P, R as predecessor, U is having Q, R. So S is having P, Q. So if I draw, so S is having so here I draw yes, if I draw 5 here, and I can connect this through dummy activity. And this dummy activity is called D1, and again I need to draw another dummy activity here, and in the final step you know why I have added these 2 dummy activities. Okay, now I am going to draw S, T and U activities. Okay, so these 2 I am going to connect these 2 dummy activities with another node, 6th node, and this activity with this 6th node, and I am writing this as, I am writing this as S, and this as, and this as U, and this as U, and this as, and this as capital T. Okay, now let us think about S is having predecessors P and Q. So S is having predecessor P, and by this dummy activity D1 it is having Q, and U is having predecessor R, as well as U is having the predecessor through this dummy activity Q. Okay, but T, what about T? So you have to think about T. So T is having a predecessors P and R. So T is having predecessors P and R. So I cannot suppose to draw connect two different nodes with two different activities and representing by the same name. So I am once again happen to draw the arrow diagram. Okay, the arrow diagram should always be connecting the ascending order of numbers. So now we can verify P Q R is having no predecessors. Yes is having predecessor, S is having predecessor P, and S through this dummy activity have a predecessor Q. Okay, U is having a predecessor R, and U is also having Q as a predecessor through this dummy activity. And now T is having the predecessor P as well as predecessor R through two different dummy activities. Okay, so this is the solution for our second network diagram question. This is the solution for our second network diagram representation question. I hope you understand these two problems. I hope you have understand these two problems. We shall discuss another two problems on another video. Thanks for watching this video. I hope you understand the concept of network diagram representation, but this will not be enough. I shall explain the same procedure and one video same procedure how to draw another diagram representation for networks for some other problems. Okay, thanks for watching.